Continue today with the series on basic mathematical skills that you will find useful during your physics learning. In this case, we are interested in talking about the properties of powers. In order to make sense of the different strategies and procedures that we are going to follow, it is important to keep in mind that we want to simplify algebraic expressions that include exponents. This means we want to end up with expressions that follow a set of criteria that is not universal, but it is generally accepted. What I mean by that is that the word simplify does not necessarily mean the same thing all the time. Some people consider that an expression is simplified if it has only exponents and no roots. Some people have a different idea. In general, we will consider an expression to be simplified if it complies with at least two of the following criteria presented. Each variable must be present only once in the expression. See, for example, this expression has variable a twice and variable b twice. We cannot say that it is simplified. Also, all exponents should be positive. In this case, again, we have some negative exponents. Thirdly, roots are preferable to rational exponents. We will see some examples of that in a few minutes. So, for our first example, we know that if you have powers with the same base, you can just put them together by copying the base and adding or subtracting the exponents correspondingly. Remember that if the base has no exponent, it is actually a 1. Therefore, this expression reduces to a to the first power times b to the negative 2. Since we don't want negative exponents, we can move the variable b to the denominator, and we have a over b squared. Notice that we fulfill conditions 1 and 2. Each variable is present only once, and all exponents are positive. Form of a rational expression. Remember that in a case like this, you are expected to subtract the exponents when you have a variable. However, we should be careful to avoid negative exponents. Therefore, we can leave the numerator and subtract 3 minus 1 and the variable b in the denominator and subtract 3 minus 1. Therefore, this expression is equal to a squared over b squared. Each variable is present only once, and all exponents are positive. The next example presents us with an exponent that can be distributed to the different bases. In this case, we have options as to the order in which we can change the expression. For example, we can write it as the rational expression n cubed over c squared, all of it raised to the negative 2. You can then multiply each of the exponents, so you get negative 6 over c to the negative 4. Finally, you can switch the variables around to change the sign of the exponents. C to the 4th power over n to the 6th power. But there are other options. For example, you could multiply each exponent times -2. In that case, you will have n to the -6 times c to the fourth power. We can move the n to the denominator, and we end up with the exact same expression as before. So there is some flexibility as to the order in which you can follow the rules of the exponents. When you have a root, the general rule is that the root represents a example. If you have a square root, that is the same as the power half. This expression can be written as a to the fourth power, b to the sixth power, all of it raised to 1/2. If we distribute the power, we get a squared b cubed. The important part here is that you don't really want rational exponents. So if the root does not cancel completely, or if you have a fraction that cannot be simplified to an integer, it is better to write it as a root than a rational exponent. For the final example, we have a numerical value that apparently cannot be simplified. In actuality, however, 32 is the same as 2 to the fifth power. Therefore, each of the powers has a fraction that can be simplified. The final answer is all exponents are positive and there are no rational exponents. I hope this gives you a reasonable good idea of how to be flexible with the manipulation of powers. As with all that we have discussed before, practice is essential to get proficient in this skill. I hope you found this useful, and I will talk to you later.